Hello guys, Suhail this side. Welcome back to my channel. This would be the fifth video in the Kafka Zero to Hero series. So we'll just firstly quickly recap what we have done in the last video, and then we'll see the agenda for today's video. Now, what we have done in the last video, we have seen the Kafka topics command, and last video was also totally the hands-on video. So we produced some of the messages using the Kafka console producer command, and at the other end we started the consumer consuming the messages from the other end, right? Then we saw the concept of offsets, where the offsets comes in picture, why it is important, and then we see where actually on the disk Kafka stores the message, and in which format the Kafka is storing the message, that we have seen in the last video. Then we went ahead and then we saw the log retention, serialization, deserialization, and at the end we discuss some of the crucial parameters, for example the timeout, max poll records, and the other settings, which are very helpful for the production use case and for the according to the application load, right? So all these things which we have discussed in the last video. Now the today's agenda would be, we would be starting the multiple consumers, and we'll see what all problems we get when we start the multiple consumers, and then we will see how we can solve those problems using the consumer group, and then we'll go ahead and we'll see consumer group in detail using the real e-commerce example, the same e-commerce system which I have already published the video on YouTube for designing the e-commerce application, and that video was in so much detail. You guys would be would love to watch that video. In that video I have gone step by step, explained each and every approach with the common trade-offs. Now without wasting time, let's get started today's video. So first of all, for this today's video, we'll just start up the Kafka server that I have already shown. So this is the compose folder which I have already shown you in the last videos. So guys who are watching this video first time, so I would highly request you to watch my earlier videos, because in those videos you will get a better idea, and I have cleared most of the terminologies, and I have already mentioned there how we can set up the Docker, how we can set up the Kafka setup using the Docker as well as in your local machine. Now let's move forward and let's start the Docker Kafka container, which we were doing like the similar in the last video. So what we need to do, we just need to do the Docker compose up, and we are done. Now if we do this, and we can see our Kafka server is running fine. Right now what we'll do is we'll just open the another tab, and we'll just split this tab and just wait. Right, so first of all what we need to do, we need to log in into this Kafka container, Docker container. How we can do that? Firstly, let's see the Docker processes, what all processes are running. Now we need to go inside this Kafka container. How we can go inside this? Docker exec, and in the interactive mode, if I pass the container ID, just need to do the bash, then we'll go into this container. Right, now we are inside the Kafka container. Now here also let's do the same thing. Right, so I'm just quickly copying pasting, and now on both the tabs we are inside the Kafka container. I'm just clearing this screen. Right, now let's split this screen once more time, and we are good to go. Right, now here also I'll do the same thing, and now in all the three screens I am inside the Kafka container. Now first of all, let's see the topics, what all topics are created. Now how we can see that? It's very simple. Bootstrap server we require to pass for which purpose? For connecting to the Kafka cluster. Right, so if I do this, right, and if I do the list command, I can see there are no topics being created. Right, now first of all, as I already mentioned, we will see live the e-commerce application. Right, now let's create the similar topic which I have already mentioned in my e-commerce video. You can assume the orders event topic. Right, the orders order events, or let's assume this is the topic, order events, right? So order events, let's assume this is the topic, and this is the topic create command. We created the topic. Right now let's see the listing again. If we do that, we can see the topic has been created. Fine. Now the topic has been created. Now we need to produce. Let's assume this left side is the producer, is the order service, which is actually publishing the orders on this topic, and the other side there are two instances of the payment service which got instantiated due to heavy load or auto scaling gets kicked in, whatever you can assume. It's in simple terms it is like there are two instances of the payment service which has been instantiated, right, for scaling purpose. Right now let's start the console consumer here, because payment service what need to do, payment service has to consume the messages. Right now here what we'll do is, here we will start the consumer, right, in both the windows in the right side. Now if I start this consumer, and on the other hand also I started the consumer. Right now let's try to publish some of the messages in this topic. Now in the left side what we need to do is, we will start the producer here. Right, so it's very simple, which I have already explained in detail in the last video. Now I'm just doing the producer. Right now this is the order service, right, and these are the two instances of the payment service as I already mentioned. Now let's publish some order, for example the order 1. Right, and ideally what should have happened actually. Now for example these are two payment service instances. Right now order 1 should be retrieved by one instance of the payment service or both the instance of the payment service, because if both the instances of the payment service would retrieve, then there is no point of scaling, because both the instances are consuming the same network bandwidth, both the instances are consuming the same CPU bandwidth. Right, so and all the data is getting transferred to both the instances, then there is no point of scaling. Now let's see what happens actually. Right, let's publish one message, order 1. Okay, now both the instances are getting this message. Right, now let's assume we are passing two message. How is the behavior? Now let's assume order 3, order 4, right, order 4. Right now if you see here, it could be fine if we have, for example, this is the instance of shipping service and this is the instance of payment service, then it is perfectly fine if we get all these order messages in both the services. But in this case, as I already mentioned, these are the two instances of the payment service. Let's assume this is the case, but in this case also we are payment service, all the instances of the payment service are retrieving the same messages again and again. So duplicate messages are being processed, means redundant messages are being processed by the payment service. Right, so how we can solve this problem? This is problem number 1. Right, scaling is not getting done, right, in this case. Right, now let's see how we can solve this problem. This is where actually the consumer groups come in picture. I'll show you there. Let me close this one. Right, I'll show you what is the consumer group. Let's discuss first what is the consumer group. Right, now let's assume this is the order service which we have already mentioned. Right, and this is the payment service, the two instances of the payment service for the demo purpose we have started, and this is the actually broker. Right, this is the actually the broker. Right, so this is the Kafka server. Let's assume Kafka server or broker, the same thing actually. Right, so this is the Kafka server. Order service has published the message onto this Kafka server. Now there could be two cases. There could be multiple services on the other side which can consume messages from this server. Right, it could be product service, it could be shipment service, it could be payment service. For this example, let's assume we have product service and we have payment service. Now let's assume there are 3 instances of the product service, 3 instances of the payment service. Right, now when the message is being retrieved by the product service, ideally only one instance of this product service should get the message and it is done, because there is no point if the same message is getting processed by the two instances, right, the other two instances as well. It would basically processing the redundant messages. Similarly, if the payment service is retrieving the message, it is perfectly fine if one of the instances process the message. If the other two instances also process the same message, then it is a kind of problem. That is no more scaling actually. All the instances are doing the same work actually, right? So there is no scaling there. So this is the problem. So how consumer group solved? Consumer group basically it creates the group for these instances. For example, this dotted lines, right? So this dotted lines, now I'll just highlight, this is the dotted lines with the yellow color or orange color. This is the dotted lines. Let's assume this is a group actually. So the product service has created its own group, right, with the three instances. Now it's a logical group created on top of all the three instances, right, on the product service or on the payment service as well. And how the messages would behave in this case? Now when we have this kind of group, only the one instance of the service would get the message, the other instance would not get the message. This is how the consumer group solve this problem. So we solve the problem of using the we solve the problem of scaling using consumer group. Right now we'll see the e-commerce application, same design, the order event. We'll see this real demo also using the consumer group. Now let's see the demo actually, and let's see this demo. Right now let's see the demo here. Now how we can, first of all we need to create the logical group, as I already mentioned. Right now how we can do that? It is very simple actually. We need to provide the group name. Right now if we provide the group name as, like, for example, the payment service, right, this is the group name, right? And in this also, if I provide the group payment service, right, so if I start this message again, right, now let's produce the message. Right now let's produce the message. For simplicity I'm just publishing the numbers only. Let's publish 5. Now let's see, the consumer 1 has retrieved it, right? Let's publish 6. The consumer 6 has retrieved, consumer 1 again has retrieved it. Let's publish 7. Let's publish 8. Let's publish 9. Let's publish 10, 11, 12, 13, 14, 15. So if you see here, now only one consumer is actually retrieving the messages, the other consumer is kept idle. Right now this is the another problem. Now I'll show you one more thing. Let's see one more thing. Let's start here as well. I'm just going inside the Kafka container. I'll create one more you can say one more consumer with the different group actually. Then we'll see the behavior, what actually happens. For example, let's assume according to the diagram which we have already explained, and let's assume this is the product service. Let's assume this is the product service. Right now if I start here, right, so if I now publish 16, right, now if you see here, the payment service is also retrieving, the inventory services, the product service is also retrieving. Now let's publish 17, right, so product service is also retrieving all the messages. Let's publish 18. Now one thing is sure now, that if we have multiple consumers with the different group, right, so for only one of the instances is retrieving the messages, right, the other all instances are kept idle. Both, they all are not actually retrieving or consuming the messages, right? So that is the problem. So how we can solve this problem? So this is where actually the partitions comes. Right now let's discuss the partitions now. Partitions and partition key. Right, so that comes with this. That is how the Kafka solves this problem. So I'll explain how it is. Now for that, firstly we need to understand how actually the Kafka works, right? So we all know Kafka is a event streaming application, right? Event streaming application. Now I have since I have already explained in the earlier videos, Kafka topic has some kind of partitions, right? By default I have shown you on the disk actually where the Kafka stores message. For example, in the earlier videos, order event 0. In here also I can show you. Let me show you here. For example, the order events, let's go, yeah, right. So this is the order event 0, right? This is the partition name actually by default. Order events is the topic and -0 is the partition 0. Actually this is where actually Kafka stores the message, right? Now if I go here, so by default what happens actually, Kafka is a event streaming application, and you could argue, okay, that if I publish the messages, the other consumer should also retrieve the messages, right? Because for example, this is a high stream of messages are coming onto this Kafka server, right? Now this is instance 1 and this is instance 2. For example, there could be a banking application. Let's assume I'm explaining you that the other consumer, why it is idle, why it was idle actually. So to understand that, we need to understand how Kafka behaves internally. So we have seen one thing, only the single partition has been created, right? Now in the single partition there could be 100 of messages are coming, right? Now for example, for the same account ID there could be one message of deposit 100 and the other message of withdraw 50, and as we have seen, the two instances are there, right? If we have started the two instances, you can say, okay, so if we have a kind of we need to achieve the scaling behavior, why not publish some of the messages here and some of the messages here, right? On some of the messages to the instance 1, some of the messages to the instance 2, so and the problem gets solved. No, that would be actually more problematic. How? Let's see how. For example, let's assume there are two messages for the same account ID, the deposit 100 and the other message was withdraw 50. Now let's assume the deposit 100 gets to the instance 2 and withdraw gets to the instance 1, and this instance 2 was bit slow. Actually this instance 2 of the transaction service was bit slow while processing the message. Now if the withdraw the instance 1 was actually fast in processing the messages, now what would happen? So it would go in, withdraw message would be processed by the instance 1 and it will see, okay, that it would check in the database that whether the user has balance to withdraw. It would check, okay, the user don't have any balance, so what it would do, it would just reject the transaction, right? That this transaction cannot be done, right? Now but actually if you see from the user behavior, so he has actually deposited 100 first and then only he has requested for withdraw. But how our application is behaving, the withdraw gets processed fast and the deposit gets processed late, right? And this is how the problems are happening, right? So this is where actually the ordering is very much required in the Kafka. And how the ordering is happening on the Kafka side, it is happening in the partitions, right? So these partitions have the offset numbers. So if you see here, which I have already explained in the last video as well, 0 1 2 3, these are the offsets which are associated to the partition, right? Now so let's assume so if we have to process all the other thing is, okay, now you would say, okay, now if we have to process all the events one by one, right, how we can solve the scaling problem? So then we can't scale anything. Now scaling is how with the partitions, with the help of partitions only we can scale as well. How? The Kafka, let's assume we'll see the demo also. Let's say the same order events topic, right? If we create two partitions, right, and if we have two instances, the instance 1, instance 2 of the transaction service or the payment service, what we can do is partition 0 would be assigned to instance 1, partition 1 would be assigned to the instance 2, and this is how the parallelism could be achieved, and this is how the you can assume this is how the scaling can also be achieved. How the all the messages of the partition 0 would be consumed by the instance 1, all the messages of the partition 1 could be consumed by the instance 2. Now you can visualize this with the 10, 100, 50 partitions. You can assume if you have 50 instances, all the 50 instances are reading from the different partitions, right? So this is where the scaling would happen easily with the help of partitions. Now when we discuss partitions, we'll have to mention some kind of partition key, right? So what is a partition key? On the basis of partition key only, the Kafka broker, right? So Kafka broker decides, okay, for the same partition key, the message should be go to the same partition. For example, the partition key is A. Now for the first time, how it would be calculated? For example, let's assume the Java hash code, right? The Java hash code function, it's like similar thing. I'll explain you here. For example, this is the topic with the two partitions, partition 0, partition 1. What is the use of it? It is going to help us in the message ordering and the scaling as well. For example, in the earlier problem, we have the account ID, right? If we have account ID as a partition key, right, and it's like a hash code function. If you have two users, right, that have different accounts, account A, account B, there are both different users, right? Now if we have the account ID as a partition key, what would be the flow? There could be a chance that account ID A would be assigned to partition 0, and there could be a chance that account ID B would be assigned to the partition 1, right? So account ID is a kind of partition key, and all the transactions on the account would go in single partition. Now all the transactions of a particular account would go in this partition. Let's assume this is the account ID A, right? Now all the messages for this A account would go in this partition. Now let's assume this is the partition D, right? Now all the messages for D partition, D account would go in this partition. This is how we can achieve the ordering, and this is how we can achieve the scaling. How we achieve the scaling? Scaling we achieved by assigning the individual partition to the individual instance. How we maintain the ordering? We with the help of partition key. With the help of partition key, the same if we have to process the message again, we have to pass the partition key, and the same partition key would be assigned to one of the partition, and further on all the messages for that partition key would go in the same partition, right? So that's how the scaling and ordering problem have been solved. Now let's quickly discuss the demo. And for example, let me close this, right? Let me close this, let me close this, let me close this, right? Now let me just for the sake of it, I'm just clearing it. I'm just clearing it, right? Now what I need to do here is, again, what for this I have already mentioned, we need to create the topic with two partitions. So if I have to solve that problem, so how we can create the topic with two partitions? So first of all, let's delete the old topic, right? We have delete the old topic. Let me see the delete command. Okay, just a second. It's very simple. How we can, okay, sorry, this is the Kafka console producer. Actually we need to, yeah, this is how we can order, or we can just do this way, right? Order events delete. So we have deleted the old topic. Why? Because we need to create the topic with two partitions. How we can create it? We can create it simply that we just need to mention the partitions. I'll just clear it so that it would be visible. So how we can create it? We have to mention the partitions 2, and we need to mention the create command, right? So this is how with the topic with the 2 partitions would be created. Now let's start the consumer here, right? Now let's start the consumer here. The similar consumer, that would be fine, and the similar consumer here, that would be fine. Now for publishing the messages on the partition, as I discussed, we need partition key, right? Now first of all, let's describe this topic, how this topic is been created. Now if you see here, there are number of partitions is actually 2, right? For this topic the number of partitions is 2, right? Now for publishing the messages onto the partition, what we need a partition key. So how we can do that? So let's copy the same thing. What will be, we have to pass the partition key, right? So instead of consumer, we need to use the producer, right? And let's do this. We need to do the producer .sh, right? And let's come, and we need to mention the key as well. Now there are some properties which we need to mention here. For example, the first one is the parse.key, that on this side the key should be passed, and the other property could be property, and that could be key dot separator is equal to colon. So that is how we need to mention. Now what is, it's actually okay, sorry. So it is property key dot separator. Okay, what is the problem? Let's run it again. Let's see. Property parse dot key is equal to true. Okay, topic order event. Okay, we don't need group. Actually in the producer we don't pass the group, right? Let's start this. Now it is fine. Now if let's assume the similar e-commerce application, one order 1, right? Now the instance 2 of this payment service has retrieved it. Now let's publish order 2. Now if you see, the order 2 has been retrieved by the instance 1. Now let's try publishing some more messages. Order 3, let's publish 4, let's publish 5. Okay, now if you see, the messages are being going into the single partition. Now the other thing is, if I will publish the same message with the same partition key which we have explained, for example, if I publish, for example, with the partition key is order id 1, has been some manipulation has been done in this order, right? If I pass this again, where it should go? It should go to the instance 2, right? So let's see where it should go. It is going to the instance 2, right? Now if I publish the order 2 again, it should go to instance 1, right? Now let's see, it should go to instance 1. So this is how the ordering has also been maintained, and the scaling has also been maintained. So that's how actually we are solving the problem of ordering and the scaling, right? But there are few things which we need to keep in mind always. Whenever we are deciding the partition key should be the good partition key. It should not be like the kind of, we can't have the partition key as which would make unfair decision. For example, we can't make the partition key as date. Now if we calculate the hash code of the date, if the date is in ddmmyy, so if we calculate the hash value, it would give the same value. So what would happen in that case? All the messages on the same day for the same date would go on to the single partition. So the load on the single instance of the application would keep on increasing. So these are the factors which we always need to keep in mind. because no matter what, how much scaling you are doing, how much whatever you do, if you spin up multiple instances as well, in that case, that is nothing gonna help anyway. Why? Because all the load is gonna happening on the single partition or the single instance. So just we need to keep this in mind always. Now if we discuss again some kind of e-commerce application, as I mentioned there, the order id is partition key, and we have seen there the order cancelled, order timeout, order booked, the same messages for the same order, for the same order id one would go onto the single partition. Right now in this case, the messages would be completely in order. It would never be a case that order cancel would be retrieved first and then later after some time the order booked will be retrieved first. No, the messages would be in order. First of all, you would get the order booked, and then order timeout, cancel, because the messages would go onto a single partition. That I have explained well in detail in the e-commerce application. Right, so this is date I have already, these are the few points which I have already mentioned, that offsets belong to the partitions, not to the topic, and we need to choose the partition key, good partition key. Otherwise there is no point of instantiating more instances. That is never gonna help. Right, and the other thing is, one partition can have more records. That's not a problem at all, until unless you have a fair distribution of records. There is no problem in this case. Right, so that was all I was trying to cover today. But before closing, so I'll just discuss few more things, one more thing actually. So you can see, I'll just show you here. So if I close this instance one, right, so if you see here the assignment, the logs here, if you see here, right, now what would happen if I try to publish one again, the order 2 again, because order 2 was going on to the instance 1. So what I'll do is order 2, right, let's see what would happen. So now what is happening, the partition rebalancing has happened, the reassignment of partitions has happened. So who is doing that? The Kafka controller is doing that. Right, so now the partition key 2 is going also to the other instance. Now let's start this consumer again, the first consumer again. Right, now what would happen again, now the reassignment would happen. Now let's see in the logs. So if you see the again the rebalance group payment service, right, so these are the logs which you might see while you are bringing down the consumer. You will see the partitions getting rebalanced. Right, now let's publish again the order 2. Right, where it goes here. Now let's publish order 1. Right, yeah, now the order 1 is going here. So that is the why it is going here now, because it is due to the partitioning rebalancing. Right, so all the partitions has been rebalanced, and due to which the, now if I publish the message again with the same partition key, let's see where it goes. It would go to the instance 1 only. If you see, it would keep on going to this instance 1 only. If I keep on publishing, it would go only on this. Right, if I publish the order 2, it would go to the instance 2. Right, so that was all I was trying to cover today. So in the next video, we'll discuss about more scaling scenarios, and I'll actually show you the benchmark results why Kafka is fast. So I have created the benchmark code which we will see in the next video, and that's all for today's video. So please guys, if you really like my explanation, do share, like and comment, and it would keep me motivated to publish the other videos much faster. So that was all, and see you next video. Thanks a lot.